Divide and conquer algorithm. A divide and conquer algorithm is a strategy of solving a large problem by breaking the problem into smaller subproblems, solving the subproblems, and combining them to get the desired output. To use the divide and conquer algorithm, recursion is used. How divide and conquer algorithms work. Here are the steps involved. Divide. Divide the given problem into subproblems using recursion. Conquer. Solve the smaller subproblems recursively. If the subproblem is small enough, then solve it directly. Combine. Combine the solutions of the subproblems that are part of the recursive process to solve the actual problem. Example. Here, we will sort an array using the divide and conquer approach merge sort. Let the given array be 7, 6, 1, 5, 4, and 3. Divide the array into two halves. Again, divide each subpart recursively into two halves until you get individual elements. Now, combine the individual elements in a sorted manner. Here, conquer and combine steps go side by side. Time complexity. The complexity of the divide and conquer algorithm is calculated using the master theorem. Example. For a merge sort, the equation can be written as this. The time function t of n equals a times t of n over b plus f of n, which is equivalent to 2 times t of n over 2 big O of n. In here, a equals 2, indicating that each time, a problem is divided into two subproblems. N over b equals n over 2, signifying that the size of each subproblem is half of the input. F of n represents the time taken to divide the problem and merge the subproblems. T of n over 2 is big O of n log n. Now, T of n equals 2 times T of n log n plus big O of n, which is approximately big O of n log n. Divide and conquer versus dynamic approach. The divide and conquer approach divides a problem into smaller subproblems. These subproblems are further solved recursively. The result of each subproblem is not stored for future reference, whereas, in a dynamic approach, the result of each subproblem is stored for future reference. Use the divide and conquer approach when the same subproblem is not solved multiple times. Use the dynamic approach when the result of a subproblem is to be used multiple times in the future. Fibonacci series example. The fib function calculates the Fibonacci number for the given input n using a divide and conquer approach. If n is less than 2, it returns 1. Otherwise, it recursively calculates the Fibonacci numbers for n-1 and n-2 and adds them together. The fib function uses dynamic programming with memoization to calculate the Fibonacci number for the given input n. It checks if the result for n is already stored in the mem list. If so, it returns the stored value. Otherwise, it calculates the Fibonacci number using recursion, stores the result in mem, and returns the calculated value. This approach helps avoid redundant calculations by storing and reusing previously computed results. In a dynamic approach, mem stores the result of each subproblem. Advantages of divide and conquer algorithm. The complexity for the multiplication of two matrices using the naive method is big O of n cubed, whereas using the divide and conquer approach is big O of n raised to the power of 2.8074. This approach also simplifies other problems, such as the Tower of Hanoi. This approach is suitable for multiprocessing systems. It makes efficient use of memory caches. Divide and conquer applications. Binary search. merge sort, quicksort, Strasson's matrix multiplication, Karatsuba algorithm,